let's start looking at polynomials with higher degree with modeling, and we're going to discover what end behavior is. We're going to predict a function's end behavior and decide what the heck these things called multiplicities are. Alright, so what is end behavior? End behavior is just the y values of a function, so the range of a function. And specifically what range it is what's happening as it approaches infinity, meaning going to the right and going to the left. Alright, or because we're already talking about the y values. The nice thing about the end behavior is that we really only need to look at the lead term, and that's it. Other than that, we can just use the nifty little chart below. Alright. Nifty little chart, let's say if it's positive and it's an odd degree, let's say that I've got an x cubed function. It's just for an example, that's something that we should know at this point. So x cubed functions look something like that. It's an odd degree, it's positive. So looking at this little piece, at my y values are going to continue to go down and down and down to the left as I am going to the left. So the limit as x approaches negative infinity, meaning I am going to the left with my x values, is negative infinity, which is my y values. Alright. So that just means I'm going down to the left. Alright. Likewise, if I have this piece, I am going to the right with my x values, the limit as x approaches now going to the right, that would be positive infinity. Would be, well, this piece is going up and up and up and up and up forever. So that would be infinity, which is just going to be up and right. Oops, I just need to put up right. Alright, so that's one that we should know. And guess what? All of our odd functions work like that, no matter if it's x cubed, x to the fifth. All of them have this down up. Alright, so what if it's positive with an even degree? So like what if it's x squared? Then, well, x squared, it's positive, so we know that that's a little happy face at this point. It's parabola with a happy face. So what's going to happen as I'm going to the left? Well, as I'm going to the left, I'm going up, which means that the limit, oops, I need to get rid of the highlighter. The limit as x is going to the left, meaning negative infinity, it's going up towards positive infinity. So again, this is my x value, this is my y value. Alright, and then I've got the limit as x goes to positive infinity, aka the right. Well, as I'm going to the right, my graph is going up towards positive infinity again. So I'm either going to go left or up and left, and up and right. Alright. Alright, what if it's negative? So even if I had like a negative x, because again, they're all going to follow the same basic thing. If I had a negative x, that's just going to be a line with a slope of negative 1. Alright, so my end behavior, well, limit as x is approaching negative infinity, again meaning, hey, I'm going to the left. What's it doing? Well, it's going up towards positive infinity. Alright, and then my limit, oops, I need to write out the full word. It's not supposed to be written out the full word. The limit as x goes to positive infinity means, hey, my x's are going to the right. What's happening to my y values? Well, my y values are going down. So that would be towards negative infinity. All right. And then finally, I have a negative with an even degree. Again, the one that we probably know the most is a negative x squared. That's just going to be a sad-faced parabola. All right. So my limit as x goes to negative infinity, which means again, my x's are going to the left. What's happening to my y values? Well, my y values are going down towards negative infinity. All right. And then my limit of x is going towards positive infinity, meaning, hey, I'm going to the right. So x is approaching the right is going to equal, well, it's still going down on this side as well. So it's going to be approaching negative infinity on that side as well. All right, a couple things to notice. I am always writing it limit with the x underneath with an arrow approaching some number, which in this case is going to be infinity for you guys. This is not optional. If it is written any other way, it is wrong. Okay? It is wrong. I don't want to see the limit as x goes to infinity. That's not correct. It needs to be written like that. Okay? All right, so it says on problem 1, please describe the end behavior of the following examples and then graph them. That should totally say then, not hen, but I guess I was too much of a chicken. All right, thank you for those of you who kind of laughed at the chicken joke, but you know. See you in my next video.